So today we're going to go over parallel and perpendicular lines. Our objectives are to find the slope of a line that is parallel or perpendicular to an existing line and to given a point in a line that's parallel or perpendicular to an unknown line, we're going to write an equation of the unknown line. So those are our things that we're going to work on today. So first of all, let's talk about slope because I want to remind you guys what slope is. Slope is rise over run, so that means we're counting about how far up we go. Here, that's our rise, and our run is here. So we're going to talk about the change in y over the change in x. So if we were to count like from a point to a point up here that's on the line, so we count 1, 2, 3, 4, 5, 6, 7, 8. We're just going to call it 9 just for the sake of this. So that's 9, and then we're going to talk about how far over to the right do we go. And so here again, we're going to talk from a point to a point. So 1, 2, 3, 4, 5, 6, 7, 8. So that would be 9 over 8. That is our slope. And we could find this if we were given these 2 points by putting in our x1, y1 point and our x2, y2 point. And again, we would put that in this formula here, which is the change in y over the change in x. So we would subtract the y1 from the y2, subtract the x1 from the x2. So slope basically means rate of change, like what is happening as we move from one point to another that creates a line. So we have a variety of different ways that we can talk about slope. If we're rising from left to right, that's a positive slope. If we're falling from left to right, that is a negative slope. And if we're a horizontal slope, then we're at 0. And the reason for that is if I were to give these some points, and this was -3, 3, and this one was 3, 3, then the way we would find that again is the change over y, which would be 3 minus 3, over the change in x, which would be -3 minus 3. So that would be 0 divided by -6. Well, 0 divided by -6 is 0. So that would be a 0 slope. And all horizontal lines have 0 slopes. Whereas over here with our vertical line, it has an undefined slope. So once again, let's put some points on here. So let's say this one is 3, 3 again. And now this time, let's say this one is 3, -3. So again, we're going to do our change in our y value. So that's 3 minus a -3. And then we're going to do 3 minus 3. Well, sorry, 3 minus 3. I'm jumping ahead in my head. So that is, again, going to be 6 because 3 minus a -3 is 3 minus a -3 is 3 plus 3. And then we got 0 here. Well, we cannot divide by 0, and that's why the slope of a vertical line is undefined. So then what are the symbols that we use for parallel and perpendicular lines? We need to talk about that because we may see that in some problems, just the symbols asking us to find that. So the symbol for parallel are 2 lines right next to each other. And then what is the symbol for perpendicular? It's an upside down capital T. Next, let's talk about what we know about parallel lines. So 2 non-vertical lines in a plane are parallel if they both have the same slope, and if they have different y-intercepts. Now, if they had the same slope and the same y-intercepts, they'd be the same line. So when we're talking about 2 lines, if they have the same slope and different y-intercepts, they are parallel. And on your notes, my notes for my students, it asks you down there at the bottom, what types of lines are always parallel? Well, 2 vertical lines are always parallel, and 2 horizontal lines are always parallel. Next, we're going to talk about perpendicular lines. So we're in the right-hand column now. It says, what determines if lines are perpendicular? Well, 2 non-vertical lines are perpendicular if the slopes of one is the negative reciprocal of the slope of the other. Sorry, there should be a space there. And also, that means we're going to change the sign and flip the numerator and denominator. So when we say negative, that means we're changing the sign. When we say reciprocal, that means that we are flipping the numerator and denominator. So an example of this would be if we have the slope of one being 4, one of the lines is 4, and the slope of the second would be the equation negative and 1/4. So remember that 4 is 4 over 1. So if we flip that, it's going to become 1/4. And obviously, if it was positive, it now becomes negative. The other way that we can determine, and this is number 2 in my notes, You can also check the two slopes to see if the lines are perpendicular by multiplying them together. And if they're perpendicular, the product of the slopes will be -1. So that's your number 2. The product of the slopes would be -1. That means when you multiply the slopes together, you get -1. So when we do this one, if we multiply 4 times -1/4, that would be 4 over 1 times -1 over 4. That's -4 on top and +4 on the bottom. Well, -4 over 4 is -1. So that's a quick, easy way to determine whether the slopes are perpendicular. Multiply them by each other, and if you get -1 when you do that, then the slopes are perpendicular. So here's your self-check. Go ahead and fill this out, and then come back to me when you're done. So parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes of each other. Remember, the negative means you're going to change the sign, and the reciprocal means you're going to flip the numerator and denominator. And then note, if two lines are perpendicular, then the product of their slope is -1. Okay, so now we're going to work through these slopes here, and we're going to talk about what the parallel slope is and what the perpendicular slope is. So parallel means same, so the parallel slope to A over B is A over B. The perpendicular slope, we're going to change the sign. It was positive, so it's going to become negative, and we're going to flip the A and the B. So this is going to be -B over A. With this one, -2, and what I'd really like you guys to do is pause the video, go through and see if you guys can do these on your own, and then come back to me when you're done and we'll talk through them. Okay, so this would be -2, and remember that's still -2 over 1, right? So that would be, when we change the sign, it's going to be +1/2. This one, same slope, is going to be 2/3. When we change the sign, it's going to be negative, and it's going to be -3 over 2. Now this is the one that I really want to talk to you about. M is equal to 0. So this is a horizontal line. And so we would have another horizontal line, so its slope would still be 0. But when we're talking about the perpendicular line to a horizontal line, that would be a vertical line. And by the way, I skipped this on the last one. If you look up there at the last part, the first box where it says what types of lines are always perpendicular, those are vertical and horizontal lines. So if I have one vertical and one horizontal, then obviously those would be perpendicular. So when we're talking about an undefined slope, that's going to be a vertical line, right? So now with this last one, I'm going to change -1 over 1.5 to -3 over 2, because that's the way I would use the slope in a problem. And then when we're talking about the perpendicular slope to that, it's going to become positive, and it's going to become 2/3. Okay, so now we're going to talk about the slope-intercept form of the equation of a line. So we're going to talk about this in a drawing first. That is our slope-intercept form, y equals mx plus b, where m equals the slope and y equals the and b equals the y-intercept. So let's just talk about the slope here. So if we go from this point up here, we're going to go down 1, 2, 3, 4. So that's -4. Then we're going to go over 1, 2, 3, 4, 5. So that would be -4 over 5. That's going to be our m. That's our slope. And then when we're talking about this y-intercept up here, that is the point 0, 4. And so we're going to pull from that our b, which would be just this value right here, the 4. So that's going to be our b. So if we were to take these two values, if you recall, and put them in the equation, y equals m, which was -4/5, x plus our b, which was 4. So this is what I want you guys to really focus in on right here, this part right here, because that is our slope. So on the next problems that we're going to do, that's what we're going to talk about. So go ahead and turn your paper over if it's one of my students, and we're going to talk about this right here. What is the slope-intercept form of an equation? Well, that is, whoops, it's going to show up here afterwards. Put it in there, but I guess it disappeared. mx plus b, right? And so now we're going to talk about what each piece means. So the y is just the y value of an ordered pair. The x is the x value of an ordered pair. M is the slope, and b is the y-intercept. So if you need to write this down, go ahead and pause the video, write it down, and then we'll go on to the next part. Okay, so now we're going to actually find the slopes of these lines. So our first line here is y is equal to 3x minus 5. That right there would be our slope. So m is equal to 3. And then our other line, y equals 1/3 x, again, we're looking for the coefficient of the x. That's going to be our m. That's our slope. So this one, the first one was 3, the other one was 1/3. Those are obviously not equal, so we know that they're not parallel, but they're also not, they don't have different signs. They are reciprocals of one another, but they don't have different signs. So the answer to this one is neither. Okay, so what I'd like you guys to do is work through the next 3 of these and then come back to me when you're done, and let's check your answers. So here again for the second one, y equals 2x minus 5, that slope is 2. Y equals 2x plus 3, that slope is 2. The slopes are equal, so this is parallel. This next one, y equals 1/2 x minus 4, so the slope there is 1/2. Y is equal to negative 2x plus 8, the slope here is -2. Those are not equal, so we know they're not parallel, but what else do we notice? They do have different signs and they are reciprocals of each other. So these are perpendicular. And this last one, y is equal to 1/2 x minus 4, so that's going to be 1/2. And then the other one is y is equal to negative 1/2 x minus 4. So notice that these are the same slope, but one is positive and the other one's negative. So these are not equal, so we know that they're not parallel, but they're also not reciprocals of each other. So this again is neither. All right, so now we're going to move on to how do you put an equation in slope-intercept form. So what we want to do is follow these steps here. We're going to move everything but the y term to one side of the equal sign. Then we're going to divide everything by the coefficient of y, and then we're going to simplify every term. So on this one, we're going to move the 3x by subtracting it. The next step we're going to do is we're going to divide everything by -4. And notice that this will cancel out here, so we'll just be left with y. And when we divide a negative by a negative, that's going to become a positive. When we divide this positive by that negative, the whole term becomes negative. So when we simplify this here, it's going to be y is equal to 3/4 x minus 3. Okay, so what I'd like you guys to do is complete the 2 in the next 2 columns, and then come back to me when you're done. So here again, we added the 2x to both sides, and we're going to divide everything by 7. So this is going to be y is equal to 2/7 x plus 4. On this next one, we're going to subtract the 4x. We're going to divide everything by 5. And I always like to change that y-intercept into an actual number so that I can plot that, because I don't know where 11/5 is, but I do know where 2.2 is, or I can at least estimate it. Okay, so now we're going to move on to the rest of this. Now this process, y'all, the purpose of this is, let me show you guys. If you have problems like this, what are we actually trying to find? We're trying to find, so we have a line in a coordinate plane, right? Have a line like this, and it's saying we want to find a line that's parallel through a point out here. That's what this first one is, okay? Then also we might be looking for a line that's perpendicular to that original line through a point, okay? So that's what we're actually looking for here. Are lines that are parallel to given lines through points that are not on the line, okay? That's what we're looking for. So our steps here are going to be to put an equation in slope-intercept form first. This is what we did in the last one, so you guys should be familiar with this. So we're going to basically move our 2x to the other side by subtracting it. And then we're going to divide everything by -1 or multiply by -1. So our equation in y equals mx plus b format is y equals 2x minus 6. Then we're going to pull the slope from here. That's our next step. Pull the slope m from the equation. So that's 2. Well, we're not going to change that slope because it's asking us for a line that's parallel up here, notice. So then we're going to use the equation y equals mx plus b. We're going to substitute in this x right here, -6, this y right here, -9, and we're going to substitute in this m too. So we're going to plug all that into the equation and we're going to solve for b, okay? So that's what I did. Got my -9 from up here. This was my y. This was my x up here, and there's my m right here, okay? So I plugged those in. When I multiply 2 times -6, I get -12. So this would have been -9 equals -12 plus b. And when I add the 12 to both sides, 12 minus 9 is 3. Then what we're going to do, let me move this out of the way. Then what we're going to do, guys, is we're going to plug this back into that. We're going to plug our m and our b back into the equation. So when we do that, we're going to leave our x and our y, and we're going to write an equation for this line now. So that's going to be y is equal to 2x plus 3. Okay, so now this next problem is similar. The main difference is that now we're talking about what kind of a slope? A perpendicular slope. So go ahead and once again put it in y equals mx plus b format first. So when we do that, again, we're going to subtract the 3x from both sides. We're going to divide everything by 4. So when we do that, we get y is equal to negative 3/4 x plus 3. Once again, right here, we're going to pull this slope. But this time, because it says perpendicular up here, we're going to change it to positive, and we're going to flip the numerator and denominator. Once again, we're going to plug in some values. Now we're going to plug this in, this 7 up here in for x, this 1 up here for y, and we're going to put in 4/3 this time for the slope. So let me talk y'all through this one because this one's a little harder. Y equals, and this time we've got 4/3 times 7, right? Plus RB. That's what we're going to solve for, okay? So this is going to be 1 is equal to 28 over 3 plus b. We're going to subtract that 28 over 3. So 1 minus 28 over 3 equals b, right? So in your calculator, you can do this. It'll go ahead and it'll show you what the answer is. But some of y'all need to remember that we can make 1 3 over 3, right? So this could be 3 over 3 minus 28 over 3. Give it a common denominator. When we subtract 28 from 3, we get negative 25 over 3, and that equals our b. So I'm going to leave that work there. You guys can pause the video to look at it if you want. But then I'm just now going to plug in what? What am I plugging in? I'm going to use this slope and that b to write the equation for my circle. Okay? So we're doing next. Okay? I'm going to erase this so you guys can see it maybe a little clearer. Okay? And so y is equal to 4/3 x minus 25 over 3. So go ahead and do these next two problems. I'll walk you guys through them when you're done. Here again, subtracted the 5x from both sides, going to divide by negative 2. Our equation is y is equal to 5/2 x minus 4. Saying parallel up here, so when we pull our slope, we're going to keep it exactly like it is. Once again, we're going to plug those values into what? This equation right here, y equals mx plus b. So we're going to put 3 in for y. We're going to put 5/2 in for m and negative 2 in. And we're going to solve. This would end up being negative 10 divided by 2, which would be negative 5. We're going to add the 5 to both sides. That's going to be 3 plus 5. So our b is going to be 8. This is our slope, 5 over 2. So y is equal to 5 over 2x plus 8. Pause the video, go ahead and do this last problem, and then come back to me when you're done. Okay, so here again, perpendicular to the line. So that means we're going to change the slope. Notice that? So we're going to work through this again, set it in y equals mx plus b format first. Move the 4 to the other side by subtracting it. Divide everything by 2. So we get y is equal to negative 2x plus 5. So our slope is negative 2. So our perpendicular slope, remember this is 2 over 1, so that would be 1/2, right? So that's going to be negative 2 turns into 1/2 when we do the negative reciprocal of it. So we're going to do half of 4, that's 2. We're ultimately going to subtract that 2 from the negative 10. So we got negative 10 minus 2 is negative 12. That's our b. So we're going to take this slope right here and put it in for m. We're going to take this b, negative 12, put it in for b, right? So our equation is y is equal to 1/2 x minus 12. Okay. So our next thing we're going to do is I'm going to remind you guys about slope is rise over run because we're going to use it here in a minute, okay? That's our equation. All right, so now I want you guys to go ahead and plot these 4 points, A, B, C, and D. So there's our A at -1, -3. There's our B at 0, -4. There's our C at 2, -2. And there's our D at 1, -1, okay? So what I'm going to do next is I'm going to draw the lines between these, and I'm going to compare the slopes, okay? So I'm going to draw a line from A to D, and I'm going to find the slope of this. So I'm going to subtract. Now look, when I do this, I could go rise 1, 2 over run 1, 2. Do y'all see that? So 2 over 2 is 1, or I can use these points and do -1 minus minus 3. That would be -1 plus 3. And minus 1, I mean 1 minus a minus 1, that's 1. So this is 2 over 2 here as well. So I don't care which way y'all do it. You can do it rise over run, or you can actually compute it using the slope formula. The next one we're going to do is BC, because it's the opposite side. And so I'm going to go up 1, 2 over 1, 2. So that slope again is 2 over 2, which is 1. I could compute it using the slope formula. Next one we're going to talk about is AB. So this one, look, we're going from A to B. So we're going down 1 to the right 1. And notice, again, that's falling from left to right. So you should know that that's negative. So we went down from A and to the right with B. So that's -1 over 1. So that slope is -1. And then we're talking about CD over here. So again, we're going to the left 1 and up 1, or we can go from D to C. So we're going down 1 to the right 1. Either way, it's falling from left to right. So we know it's going to be negative. So this one is again a slope of -1. So before we talked about what the slopes were, the slope of AD is 1 and the slope of BC is 1. So here's our AD and here's our BC. So we know that those are parallel. And then we have the slope of AB here, and the slope of DC or CD is also -1. So we also know that those opposite sides. So we know at the very least that these are, this is a parallelogram, right? So what can you say about AD and BC? So AD and BC, they obviously have the same slope, so they are parallel, right? Then what can you say about AB and CD? They also have a slope of -1, so they are also parallel. Then what can we say about AD and CD? So AD and CD are these lines right here. Well, one of the slopes was 1 and the other one was -1, so they are negative reciprocal slopes. Thus, the lines are perpendicular. Also, what can we say about AB and BC? AB and BC are right here. Once again, our slope up here of AB was -1, and our slope of BC was 1. Y'all notice that right there? So once again, these are negative reciprocal slopes of each other. Thus, they are perpendicular. So what would we call this figure? We would call it a rectangle. Why? Because we have right angles, right? And it's a parallelogram.